Hi, welcome to this video on the equation of a straight line, focusing mainly on finding the equation of a line from 2 points. Firstly, we're going to look at recognising graphs based on a gradient or y-intercept. This is quite a common GC exam question, so I'll give you a bunch of graphs and then ask you which is which. So here we have 4 different lines, and we need to work out which one of those is y equals 3x plus 2. Of course, we don't have any coordinates we can use in particular, so we have to use what we know about that basic equation. So if we look at the basic form y equals mx plus c, the plus 2 at the end, that tells us that the y-intercept must be positive. And actually that can either be this equation or this equation. Next, m is the gradient, that's how steep it is. And here the gradient is positive 3. If the gradient is positive, it goes up, going from left to right. And if the gradient is negative, it goes down from left to right. Therefore, the only equation that matches all of those things is this line here. So that must have been the equation y equals 3x plus 2. So what we need to do for these kind of questions is basically look at the gradients, look at the y-intercepts, and then basically sort of piece it together from there like a little puzzle. Let's just look at one more example where we've got to pair 4 lines with their equations. First, there's a really easy one. This is x equals minus 3. Any x equals lines are always vertical lines, and y equals are straight, flat, horizontal lines. So that must have been x equals 3. Next, let's just pick this one. Y equals 2x plus 3. So we know this is going to have a negative y-intercept and a positive gradient, which can only be this line here. Just got 2 more. Let's look at this one. Y equals minus x plus 4 has a positive y-intercept, so it could be either. However, this gradient is negative, which means it must go down, going from left to right. So this must have been y equals minus x plus 4. And therefore this would have been y equals a half x plus 1. Positive gradient, quite shallow, and a y-intercept of 1. In case these questions, you'd have to sort of use the fact that this only makes sense being plus 1 because you can see the y-intercept here is below this one, which is 4. In case that comes up as well, they're not quite as often. Okay, on to the main part of this video. That's for an equation of a line from 2 points. So typically you're given a couple of points, such as these two, and you have to write down or find out the equation of that line. For this one, it's kind of trivially easy because we have the graph to use. Okay, we can actually read most of it straight off the graph. So all equations start off with the basic form of y equals mx plus c. This is going to be y equals something, and it must be a plus 2 at the end, because we can see my y cut is plus 2. Next we can find the gradient. If I just zoom in a bit, this here is going to be 1. So if I went 1 square across, I would have gone half a square up, because if that's 3, then this is 2.5. So therefore this equation is y equals a half x plus 2. That was super easy and shouldn't be any trouble at all. What makes it slightly harder is you have the same kind of question, but they sort of don't include any of the grid lines to use. So let's go for this question here. Again, we can start off the same and actually can work out c as well. We know the y-intercept is down here, and we're told that that is minus 5. Now for these questions, the tricky part tends to be working out this gradient here. So the important thing for today's video is basically a formula you can use to work out the gradient. To work out the gradient, all you need to do is just do the difference in the y-coordinates over the difference in the x-coordinates. And the formula I'm going to write is going to look like this. So y2 and y1 are the 2 different y-coordinates, and x2 and x1 are the 2 different x-coordinates. What I suggest doing is looking at your 2 points, which are these two up here, and just labelling them. So that's x1, y1. Again, the 1's must go together. And this is x2, y2. Again, the 2's must go together. If I swap these around, it will make no difference to your final answer. You'll get the exact same gradient coming out. Okay, let's plug that in. So y2 minus y1, looking at my coordinates up here, is going to be 5 minus, and y1 is minus 5. Over x2 minus x1, that is just 5 take away 0. Then we can work this out. 5 minus minus 5 is 10, and 10 over 5 gives you 2. Therefore this gradient is 2, So we're going to have y equals 2x minus 5. And that is the equation for the line. Again, the important thing here is make sure you're comfortable using this formula here. Okay, here we've got no graph at all, but it's going to be roughly the exact same idea. First thing I'm going to do, I'm going to straightforward trying to work out the gradient. So let's label these coordinates. We've got x1 and y1, and x2 and y2. If you had a third point in the same straight line, you probably just ignore it, because you've got 3 points in a straight line. You only need 2 of them to work out that equation. So there's more coordinates, you'll feel free to ignore them. Okay, the equation to work out the gradient again is the difference in the y's, so y2 minus y1, over the difference in the x's, so x2 minus x1. Let's fill that in. Y2 minus y1 is 11 minus 2. X2 minus x1 is 6 take away 3. That simplifies down to 6 over 3, which is just 3. So now I know I must have y equals 3x plus c. We're now to work out c. This is pretty straightforward. I think I covered it in the last video. All you need to do is get any coordinates on the line and plug into it. In fact, we have 2 coordinates on the line, so we can just take either one of them. So I'm going to take 3, 2, and I'm going to plug it in here. So the y coordinate is 2, and the x coordinate is 3. I can then solve this. So 3 times 3 is 9. Solving that gives me c equals minus 7. If you use the other coordinate, by the way, if instead, let's do it in red, I use the coordinate 6, 11, and then got 11 equals 3 times 6 plus c, you get the exact same answer. You would also get c equals minus 7. So it doesn't matter which coordinate you use to work out c, because they're both on the line, they're both going to give you the same value of c. So let's finish it up. All we need to do now is write down the equation. So we just combine these 2 lines together to give me y equals 3x minus 7. And that's pretty much it. The idea is getting slightly more awkward. One thing they can do is actually write it in a different form, where in this case we can have m not being a whole number. So, firstly, let's get used to the idea of writing this new form. So I'm going to write the equation of this line. I'm doing it in the form that we always start off with, which is y equals mx plus c. So we can see the plus c is going to be minus 2, so that's where it cuts. And I want the gradient. 1 is there. So if I go 1 square across, we can see I'm going half a square up. So the equation of this line is going to be y equals a half x minus 2. So let's write it down again. Now for this question, it wants it in the form of ax plus by equals c. And it wants a, b and c to all be whole numbers. That's what integers means, by the way. Integers is just another word for whole numbers. So we can't have any fractions. So my next step is I'm going to double my whole equation. And again, if you're doubling an equation, you have to double each term. And a term is anything on another side of the equal sign, or any 2 terms separated by either a plus or a minus. Okay, so these 2 terms are times together. So these 2 things are times together, so they're just 1 term. So doubling this equation, I'm going to have 2y. For double half x gives me x. And now I have minus 4. It wants us to write in this particular form, ax plus by equals c, and it also wants to make sure a is positive. So we have to keep x as positive. So what I'm going to do, I'm basically going to swap around the 2y and the minus 4. So now I'm going to have minus 4 becomes 4 when it changes side, and plus 2y becomes minus 2y. And then we're done. There's just a different way to write an equation. It's still the exact same equation, but just some questions you have to write it in a different form, just, I don't know, for the sake of it, really. Okay, let's see the idea in a slightly more full environment, which is slightly harder. So this now is going to combine both skills. We need to first find the equation of a line from these 2 points, and then after that, we need to write it in this special form. Okay, first step, we can label these coordinates, and then we can work out what m is. So x1, y1, and x2, y2. M is going to be y2 minus y1 over x2 minus x1. Again, let's plug that in. So that is 5 minus 7 over 7 minus 1. That's going to give me minus 2 over 6, which simplifies down to minus a third. So that's my gradient. And again, I'm going to ignore this now. You always want to start off with getting your equation in the form y equals mx plus c. So let's work out what c is. Again, we can take either coordinate. I'll take the 1, 7. And we're going to plug that in. Okay, solving this, we can see that 7 is going to be minus a third plus c. If I take the minus third across, it becomes plus a third. So therefore c is 7 and a third. For these equations, if you get a fraction for c, your life is made so much easier if you write that as a mixed number. So we just do 7 times 3 plus 1 to give us 22. So 7 and a third is equivalent to 22 over 3. Okay, let's combine these two together. And then we have our equation for our line, y equals minus a third x plus 22 over 3. However, again, we want it in this particular form. We want a, b, and c to all be whole numbers or integers. So my next step to go along here is I need to triple this whole equation. Again, we're going to triple each term. So triple y is 3y. We've got minus a third x will just become minus x. And 22 over 3 tripled just becomes 22. This, by the way, is the main reason we wrote this as a topic fraction. It's a lot easier to triple this than it's to triple 7 and a third. Okay, next you want to in ax plus by equals c, where a is positive. So all I'm going to do is take this minus x across and it'll become positive, which gives me x plus 3y equals 22. And I'm done. And again, we picked this particular form, ax plus by equals c, because it's nice to have an equation where you don't have any fractions involved. Okay, I hope that helped, and thanks for listening.